Manufacturing Hub. If you guys are new here, welcome. If you've been here before, like our guest, David Nichols, welcome back. We'll go ahead and introduce David or reintroduce David and catch up with him in just a minute or two. As we go ahead and jump into that, I wanted to introduce the new theme, right? So this month we're talking all about factory hardware reinvented. I want to shout out and thank Horner Automation Group, who is our sponsor, first-time sponsor for Manufacturing Hub. So thank you guys for coming to sponsor the show, and thank you guys for helping to drive conversation to places that we haven't gone. As we've talked about, somehow we've made it, almost 3 years of this show and haven't had a outside of standard factory hardware conversation for an entirety of a theme, which honestly is just shocking to me. I will say Horner Automation also does lighting, and as much as I've tried to convince Vlad to do like lightsaber fighting with safety standard lights, I haven't convinced him yet. You guys go ahead and tell him in the chat if you want to see him do that. I also haven't told him about it yet, so go ahead and publicly shame him for not being in a lightsaber battle with me to go ahead and kick off of this show. If you guys are new here, we do our very best to have a lively chat. So if you guys have conversations, questions, comments, either for us or in and amongst yourself, please feel free to go ahead and drop them in the chat. Please feel free to go ahead and talk with everyone else in the chat. If you guys have questions for us, we will do our very best to answer them both on the show. And if we don't make it on the show, we do our very best to come and answer them after the show. But without further ado, everyone, welcome to Manufacturing Hub. I am Dave. This guy up here is Vlad. We've got a very special guest this week, David Nichols. David, as I was looking back, you have been on episodes 29 and 53 in the past. So welcome back. Thank you for being here.
Ready to go again.
David, thank you so much for joining us.
I hope to be like the Tom Hanks on SNL, like the record holder, the continued record holder. So if that ever is in threat, just call me and we'll keep it straight.
Okay. Awesome. We'll definitely invite you over. That is an important, ever-moving goalpost, I feel. But David, for those of the viewers who have not seen one of your last episodes, could you please give us a reintroduction? And I know that we're going to have a very interesting conversation. You're working also on a few new initiatives, so want to hear about those as well.
Thank you. Yeah, my name is David Nichols. I'm the CEO of Loop. Loop is a automation engineering company that I founded with my business partner, Carl Robrock, back in 2007. And really the mission of the company is revolution and innovation and bringing new technologies and making those kind of big impacts. Some of the things we'll talk about today are definitely of that type. And over that time, business-wise, we really started as a hardware distributor. And maybe that's what we'll talk about today, hardware. We've always been working with, I guess, alternative to the norm, unconventional hardware. Maybe we started as a B&R distributor, and we still are. So it's a big part of what we do today. And we also do a lot of consulting engineering. We do a lot of automation software engineering. So that's an SI really focused on doing controls development. We do that through our Ship and Six team, which is focused on agile development projects in that world, helping machine builders or big end users, or really helping usually new machine types come into existence is kind of our favorite. So looking forward to talking about that, and happy to share anything else.
And I really like the fact, that you've mentioned software as well. I think that the two often go hand in hand, but I want to say in the traditional control systems approach, you're very much, I want to say, restrained by the hardware, right? And so you're given a certain platform that you want to work on at a facility, and then you're like, well, this is what it's capable of doing, so that's the software we're going to write, right? And so you're taking a slightly different approach where you want to do software the right way, and ultimately the hardware also needs to some extent follow, right? And I'll let you maybe expand on that a little bit, but ultimately, sure. I think that you have applications in which you've seen that the hardware needs to be different than what was maybe originally thought or spec'd out in order to meet the requirements, right?
Right. We'll talk about it more, I'm sure. But a lot of our work was inspired by software engineering, the principle of software engineering coming from the IT world, I guess, is what industrial folks would say. And keeping tabs on that, learning about that, looking at all the tools and techniques that a lot of companies are doing, working with tools like JavaScript or Python or HTML. These are all and not only that, not only the platforms, but also the development techniques. How do you run a team? How do you build complicated systems that are digital software systems? These are all things that have a long history in the IT world, and there's a big applicability, I think, to many industrial automation applications if we're able to do that, if we're able to bring those techniques across. And so, yeah, the hardware needs to be able to do it. The software that runs the hardware needs to be capable of running a lot of those techniques and tools. And so, yeah, big theme of ours is how do we get all those techniques from those types of systems from software engineering over here into machines. And machines run on industrial hardware. We need the industrial hardware to be able to absorb. We need to be able to do that work on real controllers, on real machines that are running production.
And if I want to ask you maybe like a more general kind of question to stay consistent with the theme, what kind of innovation maybe are you seeing on the hardware side? What kind of maybe requirements are you seeing us meeting a little bit better when it comes to hardware? And maybe also like what kind of challenges are you seeing in the manufacturing space specifically, right? Because I think that saying, well, we can have a machine that runs Linux, I think that's great, but ultimately manufacturing has very specific demands as well, right? It needs to be fast, it needs to be highly responsive, it needs to be consistent every single time. So I'm curious, like, what your thoughts are on the innovation of hardware.
Yeah, absolutely, and I think it's really a convergence type of question because, and I wouldn't suggest everybody throw Linux onto their machines, every machine. It's, you know, what are the right tool for the job? What are the things that it brings that are important and necessary for the context? When you talk about industrial context and controls, there's incredible reliability demands and lifecycle demands. You're shipping machines that you need to support in the field for sometimes decades. The equipment needs to have that kind of longevity. And so all the platforms and all the tools need to support that. Otherwise, your investment goes away. You're non-viable, right? You can't throw hardware on there that's not going to be available in a couple of years. That's a dead end for your production system. So you have all of those demands, and industrial players are really good at that. And they've been doing it for a long time. But at the same time, you also need to be able to evolve, or you also need to be able to incorporate these new things at the same time. So I think the personal story for me was working with motion controllers. I worked for a distribution company that was selling Galil motion controllers and, you know, servo drives and all the kind of like high-tech motion distribution type of thing. And it was really cool what you could do with those discrete electronics, but it would be a 2-letter command, SH, servo here, and turn on the motor. Like, it was that kind of scripting that was on a motion controller. It's embedded, like really an embedded device. And then I was working in that job, and one day we started working with B&R, and I opened up the tooling, and it looks like an IDE. It looks like for Visual Studio. There's a ladder editor, and then you click over here, and there's a C compiler, and you can write, and you can just throw it all together, mix it all together in the machines. And I knew from my experience with software tools what I could do with that. I knew that if I had really open APIs, if I had the ability to write C code, I can do literally anything that C code can do, which is, well, just like look around you, the entire world is built on C code, basically. And so that seeing that capability and thinking about how that could be applicable in machines, that was something that got me excited about B&R right away. That's been there. So even something like that. And again, I also wouldn't suggest that people sit down and start writing C code in their machines. It's just speaking to the possibilities, the openness, the flexibility. You need to write your own weird TCP driver down and bit bang on what is, go knock yourself out. Go ahead. You needed to do that. You can make it do that. That flexibility was something that I saw a lot of applications for. I was excited to use. And so
it's open to that extent. I guess like I've not really experienced maybe the B&R platforms. Interesting.
Yes, Vlad. Yes, it is. You want to go down to the socket level, and yeah, I mean, and there are times when we would take advantage of that specifically because we had something we needed to do. We need to go all the way to the bare metal and say, here's the exact bytes of this packet I want you to shoot out every couple milliseconds. We built our own WebSocket drivers. We did crazy stuff because at a certain point, yeah, the vendor is going to provide a great platform for you, and they're going to provide interfaces to all their hardware, and that needs to be awesome. It needs to be great. And when I need to make something or I need to do something, I also need to be able to take it to that level, right? That ability to open it and crack it open and do something that solves a problem, that was really important to us. Or we just saw the opportunities. It was exciting, and what that led to was solving problems in different ways with software tools that were really valuable. All different types of problems, but there are different ways that showed up, and we really relied on that flexibility and that openness to be able to do that. And it's different. It's different skill sets. There's a lot to talk about there, because the other thing that I remember talking about over the years was it's a really sharp set of knives, and you can really get in trouble. We would talk about, here's your train tracks, here's one platform, here's your train tracks. This will take you to St. Louis. Just get on and go, and you'll get there, you'll be fine. And if this is just, hey, just throw you in the wilderness and, make your own way, you can get lost. It's like the limitations can be helpful when, for different reasons. And so when there were no limitations, or you could just do whatever, you can really screw it up, to be honest. You can also make whatever you do what you need to do, right? It's a trade-off. So yeah, that's something that we really relied on. But I could see that software capability back 20 years ago. Like that was the case 20 years ago. And then 10, 15 years ago, we started picking up things like Git. We just started using Git. All of B&R's entire project tree, everything, all the IO configuration, all of the software, everything was just text files. It was text files so that it could be controlled with source control. They made that on purpose, right? I was around when they made that transition from just having like one binary block, a bunch of binary stuff, to just everything can be source controlled, and it can branch and merge. And this is 10 years ago. So those are the kinds of tools. And again, if you work with software engineers, you're familiar with those, that in the kind of the IT world, those are essential. And there's really important reasons why those teams depend on that stuff. And we can do that in automation. That's a big theme of what we're doing. But the platform has to do it. It has to be a legit platform in the factory too, in the supply chain, are you going to be able to deliver parts? Are you going to be able to still ship me the same controller 10 years from now that you did, back then? And yeah, there's companies that can do that, that can do both.
David, any interesting projects that you can or are able to talk about? I'm not sure what has been openly released. I've certainly seen multiple videos from your labs. I know that you guys have, in addition to B&R, you also have robotics, you have Boston Dynamics videos. Any interesting stuff that you're able to share?
Well, let's see. Well, a quick comment on labs. We made labs so that we could do demo projects that looked similar to work we had done, but was not under NDA. So we would make up projects, and we would say, this is a demonstrate. Imagine, if you will, squint at it. It looks like some stuff that we're doing with people that we can't tell you their name or what they're doing. So that does sound very cool. And I'm also sometimes struggling to think of the answers, especially in contexts like this where it's really public. I think I can speak generally. One example that I'll list is, and where the platform and the software was really important, was we worked in aerospace. And in aerospace, first of all, they have just incredibly demanding applications. They'll gigantic scale, insane accuracy requirements, ridiculous, not ridiculous, very intense throughput. Everything needs to, they're making big things and super accurate, and the throughput needs to be good, and it just unlimited, well, whatever you can do, like we're here for it. And so we worked in applications like laying down carbon fiber tape. And in those cases, we were taking all of the robot kinematic controls and all of the IO system controls, which are sub-millisecond, synchronized to the path and the motion, and then 30 other motion control axes. Everything is perfectly clock synced. All of the mechanics have been laser measured and compensated, and either beforehand or in real time. All the software systems that can make that stuff work together on one controller. Those are the kind of things where the performance needs, we need software tools to be able to do that. We need software tools to be able to do all the calculations we need to do and have it be real time. And those are solved often, or with platforms that had that really computing and networking flexibility to them. That's what we needed to do that. There's other ways that people have done that, but I'm pretty proud of what we've come up with, and where we would just sort of engage in that in a digital way. And do all the development of it in digital twins. Like that stuff like that was really important to us, essential.
I've got many questions even on that application, but I want to bring Dave into the conversation as well. Dave, what are your
Sure.
thoughts?
Well, I appreciate that, Vlad. I wasn't 100% sure if I was going to get anything, any say in the next 45 minutes of conversation, but thank you for bringing me in. But no, David, I really like the comment that you had talked about, right? Of there are lots of standard use cases, and you get on the train and it takes you to St. Louis, and you don't have to worry about it. I think a lot of what we see you put out in labs and a lot of what we've come here to talk about is those non-standard use cases, right? There are lots of non-standard use cases that we can't go put our standard controller, our standard motion, any of that in. What drew you and the team at Loop into a bunch of these non-standard use cases, and what have you learned in the last decade or so of
Sure.
running Loop?
Yeah, I think I mentioned it earlier in this conversation, but when I saw I can run what I consider to be what any software engineer would say, this is a legit software tool. And in the same tool, on the same controller, side by side is ladder and everything else you'd want to do in a machine, and they work together seamlessly. That was something that I was really excited about exploring because of what I had seen. And it's an alternative. It's like it's hard to talk about, or it's confusing to talk about in the United States because we talk about it being like alternative or it's nichey, and at the same time, I don't know what the recent stats are with B&R, but they crossed $1 billion in revenue a while back. Mm-hmm. And so there are major companies and businesses and equipment builders and that are depending on this. This is not a small time operation, right? And they're not the only one that's like that. You look at like Beckhoff's and stuff like that, and you look at the growth charts, they're a lot steeper than anything else out there, right? So this is serious stuff. It's been around for a long time. And so I guess that's just the first thing. There are enough of those out there. It does exist, right? That's just like, you can just see from the numbers that there's a lot of people that made that choice to do something different. And I would almost talk about it this way, which is that it's sort of an existence proof. Like, why would you use a controller from Austria that no one's heard of? Like, why would anybody do that? It makes no sense. Why would you do something different? And the answer is, well, they did do something different. There must have been a reason. What was the reason? Why would you do that? Why would you pick up something when there's text on every corner, there's distribution on every corner. You can call up anybody and get them to program, your Rockwell PLC, for example. Why would you do something different? And it was always because there was something about the capability or the way it solved the problem that was really important. It had to be that important in order to take on something that was different. And that's a trade-off, right? It's different. It's not, it's still maybe not the market, it's like I don't even know what market share numbers would be, but it's got to be single digits for a lot of this stuff compared to the juggernauts. Yep. And so there would be cases where they'd say, this is important enough to us that we will, because of the machine performance, because of the flexibility, because we tried to do it the other ways and it didn't work, or it only worked at half the speed that we wanted it to. Or they say, it depends on the industry. There's different industries. Some machines are more like appliances, and all the users care about is, oh, cool, it can do 20,000 units per hour instead of 10,000 units per hour. Like, write the check, like, do it. We don't care what's inside. Or we do care what's inside, but it's worth it to us too. That it would be different. Those are the cases. And what I really liked about it from a design point of view was you had to be that good. Because the other thing, and B&R would say this too, or would have different debates with them too. We also, when we would compare side by side on like a bill of materials cost for a machine, we would often be with B&R 30% less cost than the standard.
Interesting.
I would have these discussions or arguments with people. I don't know if it would be an argument. I would be making the case that's not good enough. That's not good enough in and of itself, because it's fine if you save 30% on the controls cost, but you have to look at the whole thing. That's just looking at the controls of the machine. You have to look at how are we going to service it, how are we going to put it in the field. If you're a giant CPG user, you can't have 100 different varieties coming in here that you have no ability to deal with. Like, that's just unacceptable. It doesn't matter how much. And I've seen CPG companies make that choice over and over again, where they'll pay a premium for the consistency because of how important it is. And
Yep.
that's a valid choice, right? So my point was always, we will definitely save money on the BOM because the hardware is more cost effective. That's easy.
Mm-hmm.
But that's not good enough. It has to be even better than that. The machines have to be so good that they're undeniable in terms of their performance, their flexibility. And we would have a lot of different cases in our history where we were talking with people and solving problems where that was the case. Like we worked with a woodworking company that makes feed-through machines, and they have a lot of variety. They're an OEM, like they're a machine builder OEM, and they wanted to be able to do really dynamic things with their equipment. On the one hand, they want to be able to just walk up the machine, punch in a bunch of numbers, change the parameters of the cuts that it's doing on the fly, and just run it on the tool. And they try to do that kind of UI stuff with other platforms. It wasn't possible. The other thing that would happen, or they tried it and didn't work, they had to do it in Excel and then come back and punch a bunch of numbers on the HMI. I mean, I'm sure we've all seen machines like that, but we help them do that on the tool, like right on the front end of the tool. You could change everything about how it cut. And just as an example, that machine, they would build different types of machines depending on what type of throughput. Sometimes they'd have a big tool maker on them. Sometimes they'd have 2 stations. Sometimes they'd have 6 stations. And we made her to be a double-sided machine, single-sided machine, double-sided machine with an outfeed table. Like they had just a million options. No machine was built the same way twice. Mm-hmm. And we helped them come up with one project that addressed every single machine, both the ones that they had done in the past and the ones that they're building in the future. And as it changed, or as we did new features, we would be backwards compatible. I mean, again, I'm sure there's exceptions, or, again, call me out if you know the details. I'm sure there were edges, right? But we would be able to do stuff like we fixed a bug on a machine over here, and we revved the software, put it out to every tool, right? And we could do that with the software tools and the flexibility of the platform, and that was worth doing something different compared to what they've seen before. And again, that was 15 years ago. So there are cases like that with and that was an industry where the users aren't as particular about what's inside the tools. They're used to just buying machine tools. It's like a black box anyway. They just care about making kitchen cabinets or whatever. So yeah, that was a good example of where the flexibility and the software tools like really made a big difference, because we just had an array of stuff, and the HMI would change and grow and shrink, and it was worth it, and they would do the engineering, and our goals was really to make it so that the machines didn't hit engineering before they went out the door. You just dropped the standard program on them, on every single one. So that was that's an example, and there's many others.
No, I think that is, I think it's one very interesting. It's certainly something that very few groups are able to do. And I think that goes back to the point of melding the hardware and the software together. I think that you could have the best hardware in the world, and if no one knows how to use it, right? If it cannot be built to be able to utilize, then you're not going to be able to get the most out of it, and no one will know, and you'll be a significantly smaller than $1 billion offshore company that no one has heard of. And from my understanding, I know we talked a bit about Ship in 6. That is part of what you guys are doing internally. Can you tell us a little bit more about the concept of Ship in 6 if people are not familiar with it, please?
Yeah, absolutely. We developed Ship in 6 because we started from working in distribution, and we started by going to people and saying, we have different ways of solving problems in machines with this hardware. These tricky problems that maybe stumped you in other cases, we think we can solve them. In fact, we think they might be easy to us. We can do that, or we can help you do that. And so occasionally people would give us a shot, and then we would help them do this work on a new platform, a new hardware they've never seen before. And we would often be working on new prototype machines. And so we would often sort of, by the way, if you want help on this, imagine sitting down, you're a controls engineer, you worked on a certain platform your whole career, and then you just get chucked in front of this, hey, here's this entirely new thing. And by the way, blank sheet of paper. And that is not a great place to be. Like, I wouldn't recommend that. And so often we would go and say, we can help you lay out the structure. We can help you get started. It's your responsibility, it's your code, but we can help you do that. So we built that consulting team to help with applications, to help with, let's make that woodworking machine. Let's help them design it, because we've done 50 machines on B&R. We've done 100 designs on B&R. We know how to lay it out. And so that was where Ship-in-6 came from, was doing that applications engineering development work. And we got into a couple places where the development work and the difficulty of the equipment we were working on became so big that like it's more and more demand. We got involved in a Boeing program that just got bigger and bigger and bigger, still getting bigger, or it'll go away. I don't know. It could also just vaporize, but it keeps getting bigger. And so those skills were applicable to those machines, and we started finding other places. And we had always worked in the Northwest and Northern California, but even in the US, there's B&R users all over the country that are making that choice for their machines. And so because of personal connections or other outreach that we did, we would say, hey, we can help you make this stuff really work well. We won't be your channel. We won't sell you the parts. Keep buying the parts from whoever. Maybe buy them from B&R, maybe buy them from another channel partner, but we can help you on the development. And there have been some really powerful and rewarding collaborations where we've come in and helped people really, really do that. And Ship-in-6 is the idea that we use iterative and agile processes, which are also straight out of software engineering as a technique, because I think that technique emerged out of software engineering, I think, from the difficulty of building really complex systems. It's hard to specify them a long time in advance. You have to almost grow them step by step. And those techniques came out of building large software systems, and they apply to tools, especially tools that have that kind of like really digital backbone, really, really software intensity. Like building them step by step in an agile process is really effective, really effective. And so that's kind of why we called it that. It's named after our sprint process.
Interesting. I like that approach. I'm going to be posting, by the way, if you're listening to this in podcast form, there's going to be links in the show notes so you can check out all these references and more. David, as a follow-up, and maybe as I steal one of our last questions, I want to know what your thoughts are when it comes to hardware, right? I think that someone in your position is seeing this firsthand. And ultimately, I think the edge cases drive where the industry is going to shift. But ultimately, I'm curious to hear your thoughts on whether you're seeing, because I think a lot of platforms are releasing, let's say, Linux alongside of their controllers. There's a lot of conversations about virtual PLCs. So are you seeing maybe, like, what are your thoughts on specialized industrial hardware when it comes to controllers, right? So I want to say, like, obviously it needs to be robust versus, it runs now on our server, whether it is Windows or Linux. I guess that's not overly important, but how do you see the hardware evolving in the automation space?
Yeah, absolutely. There's a whole galaxy emerging, basically. This would be my thought. And I think the theme, or at least the theme of our work, and I think the theme of what we're going to see in coming decades, is the influence and impact of software tools and digital systems on machine. You can call it Industry 4.0, you can call it whatever you want, but taking those, and the way that I would label that would be computing and networking, and in machines, real-time networking. That's a different way of solving problems than embedded devices, even field buses, compared to before. It's like we're solving it with those tools. And sometimes that means we're using a real-time operating system in a B&R controller, and it's running ladder, and it's running a bunch of C++ code. And that's just a self-contained machine. It's sitting there, there's like software in the machine, network and real-time drives on the machine. That's a good example of it. And that's really how we got started. There's other ways to reconsider it as you think about building different types of systems, where you say, we don't need to do all that in the machine anymore. There's parts of this that are better done in other places. There's parts of this that are better done in the cloud. There's parts of this that are better done in Lambdas on AWS. So as this tool emerges, what's the right way to put these things together? What's the right way to divide it? And as a designer, as these technologies are emerging, you're like, which tools do we pick out of the toolbox to solve this problem? And what's really important to me is that we can get software tools and networking tools and that digital stuff all the way down to the servo drives, all the way down to the IO system, like all the way into the machine, because it's not just some layer that you stick on top of a bunch of old, relays. We got to get software all the way down in there. And so that's also where we really specialize. So where you draw the line and how you put systems together, it's still a constantly changing puzzle. But
do you think we're not going to converge towards like one maybe like good design, or you think we're going to have like just an array of different tools that are available for engineers? I guess I
You
go
can,
back and forth. I don't think there's an answer to this, at least from me.
I don't think
Because
so. Like, I think you can, if you go like full Elon Musk on first principles of how, what are the trade-offs, the things that are really important in machines are speed and determinism, like low latencies, clock determinism, because you're controlling physical motor, you're controlling physical systems. It needs to be real time. Other stuff doesn't need to be real time. It just needs to be really fast, which is not the same thing, right? And so as you start to think like, okay, I can get back and forth to AWS in 20 milliseconds. There's a lot of problems that you can solve that way, but not every problem. And what's most convenient? What's the right way to structure this? Where are machines going? What's that like? Is this more like a machine tool, or is this a production line in a facility? And like there's different contexts for what to use. So I think sometimes we're definitely saying, yeah, let's get that off the machine. Let's use deployment systems where we just check in the code and it just shoots it out to 1,000 machines like that. That's smart. That's using the new tools to be able to effectively deploy where you just never would deploy before. Or you couldn't deploy because every machine was a unique snowflake because you weren't using software engineering tools to manage the complexity and the variations, right? Like there's all these, it shows up in all these different places. So I don't think there's a unified architecture emerging unless, I just can't see, I don't really see hardware getting that commoditized where it just doesn't matter what you run it on, right? Like no one knows what AWS is running on. Like, I don't know. I mean, maybe they tell you, but like, you don't care, you don't know. It doesn't matter, right? And in that industry, it went that far that you don't even know. You don't even know who made the hardware because it's
interesting,
so
right? Like,
we can get there, but there has to be enough standardization. In IT, Linux was that, but Linux still has all these quirks. And I've talked to people, and I see what they're doing too about like, let's just put a Linux real-time system down here and have that do everything. And it's good at a lot of stuff, but there's also tricks and trade-offs of, well, Linux wasn't really made to be real-time in the beginning, so it's a bit of a bolt-on. There's some quirks, but maybe that's good enough. I don't know. There's a lot of these things in hybrids emerging. I think I still like that companies like a BNR or another one that we appreciate, especially in Ship and 6, would be like a Beckhoff. They're providing you a good platform. They're giving you the tools. They're managing all the APIs. They're managing the lifecycle of their products more so than you would get even from other industrial companies that didn't care much about consistent availability, lifecycle management, stuff like that. That you need that. You need that for tools that have a long lifetime. So I think I don't know that part of the problem is going to be solved in a way where you just don't care anymore. Because I think we saw that people were imagining that even back in the 90s, because they thought like, well, we'll just put a Windows computer on here and that'll just be at the center, and then doesn't matter what Windows computer. But then you start shipping machines with Windows computers, and there's border revisions and IRQ changes and all this crazy stuff that comes up that there's no consistency in it. So it didn't work, right? Or it worked okay, but there were all these like, you got to make it, there are all these complexities that were not controlled really. So I think that's a puzzle that's to be solved, and it's more important that we can use the digital tools and have a legit platform. Like as a BNR user for a long time, like I still do appreciate that. Like I like walking around and then being like, we can tell you the serial number of every component that went into this part anytime in the last 15 years, and you're like, damn, like that's really cool. That's important for industrial users who, when stuff goes out, or safety components. Like there's no reason for it to be legit industrial hardware, for sure.
Yeah, and it's interesting, right? Because again, as I've said, I think many vendors are releasing sort of not necessarily software agnostic, but I want to say hardware that can run like different applications, right? You can,
yeah.
Essentially, if you have an IPC from whichever brand, whether it is Siemens, Allen Bradley, Beck of BNR, like you can drop any application that you wrote on Python, and in theory, right? I don't know. I've not seen it in practice, but if you have a machine that runs whatever IPC, you could just plug in a different one, and in theory, it should be able to pick right up. But yeah, it's going to be interesting to see. And again, to your point, I think we saw that divergence back in time where PLCs were almost necessary, right, to run production for many reasons. And now I'm almost seeing this kind of reconvergence, but I don't know how close it's going to get. I don't think it's going to go like all the way, but it certainly is like a question, I think, for many like manufacturers, OEMs, integrators, because the tools are technically there. But
well, yeah, and in terms of reliability, like I think when I was earlier, or when I was really even more militant about like everybody should use this new stuff, it's obviously better.
Mhm.
You know, I was like just so full of certainty about that. I think that's because technically, unquestionable better performance. Like commercially, in terms of how much the hardware costs, like definitely better value. But then you're talking, but what I was missing, and I think what's still the case, is that's not the only considerations. It's like, what's the community of people that know it?
mm-hmm.
What's the community of people in this company that know it?
Mm-hmm.
And what would it take for them to learn a new thing? And that is such a mass, it's such a inertia, that it's a legitimate reason to not change until something comes along and you're like, we need that, everybody needs to learn this. And I've seen that happen lots of times. And there are places where the most dyed in the wool, whatever, the most dyed in the wool, you know, we're only AB, I guess is usually what they say, until something comes along and they're like, yeah, we want that, we're going to do that now. Like, and just they throw a switch and, you know, all their techs are learning some new thing because it's important to the business, you know, or they saw how it would impact their, you know, oh yeah, if we use this is what our equipment would look like if we use something new. Like, I guess we could train some people. Yeah, like go do it, make it so. You know, like it's just like eventually, like there are breaking points. Like those companies do have those breaking points, and I've heard a lot of stories, and I've been hearing more of them recently because some of these companies, some of these newer platforms like BNRs and Beckoffs and whoever are really getting a lot of influential attention from places that have adopted it for those reasons, or adopted it 10 years ago. And you look at what they've done with it, it's really, really impressive. So I feel a part of that kind of crew and the people that are doing that. So
no, absolutely.
It's creator territory. Yeah.
I certainly appreciate that, right? Like from your side. And I know that you guys are a huge proponent of, you know, exploring different options. I think at the end of the day, it would be almost, I want to say, reckless to just pull the plug on everything the next day. But I think you should have some knowledge of what is available out there. What are the best practices? I think that it's almost good practice to look around and kind of exploring like what are other companies doing, how is it done, like elsewhere, what can we leverage, because I think like the technology space is moving at a faster and faster pace, so you need to have some eyes on what's going on and what could make sense from a business perspective, right? Like I think ultimately we talk a lot about automation and kind of we're excited about the technical specs and what's possible. But I think you need to internally analyze, well, like what can we bring to the business? Even as an automation engineer, if I can save money on, you know, let's call it repair time metrics for my company, then I can make that that use case. But no, I absolutely agree. I think that there should be more, how to say, like sites outside of your current I want to say immediate reach. And again, that's my opinion. I know that there's definitely business reasons why companies are locked in, some of which you've mentioned. But yeah.
And it happens slowly and then quickly, right? That's what that curve looks like. It's slow or nothing's happening, and then it starts to move, and then it just goes up like you know, like. And we're still in the, for some of these newer platforms, even though companies like BNR are 40 years old, they're as old as me. They're still hitting. They're just starting to hit that part of the curve where they're going to start getting real big, and I feel very confident about that. And ABs and Siemens don't have to go away for that to be the case. Like these companies, you know, a few companies that are going to represent sort of this new way of doing things they're going to become huge. Like there's no doubt about that to me.
I want to take the conversation slightly back to the point that you mentioned, that you don't think that hardware is going to be commoditized enough, and it will basically always, at least in our lifetimes, matter what type of hardware you're running. And I would generally agree with that. I want to ask you a question that Vlad and I debated on our previous theme recap for an untold number of minutes just last week about universal I/O. Now, okay. You haven't been prepared for this. So before this question, I will tell you that I didn't realize that anyone could say the phrase universal I/O so many times over the course of about 6 minutes until Vlad and I had this conversation. But talking about moving forward what the future of hardware looks like. Do you imagine that we're going to see more companies adopting universal I/O? Do you think that we're going to? Yeah, I guess. Do you think we're going to see more of that? What's your thoughts on universal I/O?
Well, I probably have to hear how you guys define that, because I think I know what it would mean, or I know what it would mean to me.
Yeah.
But do you mean, tell me more, like just roughly, like what's the two sentences on that? So just to make sure I have it right.
So I think we were defining universal I/O as basically user configurable I/O, right? So it's not going to be everything, but you know, one module is going to accept a whole bunch of variety of different inputs, so you don't have analog and digital and all of these different types of inputs and outputs.
I see. Okay, no, I was imagining something different.
Well, what were you imagining? Because that might be an even more interesting conversation.
Well, it's kind of. I'll answer both. So one would be about what there's like a far future vision, or maybe even a near future vision, of why do we need all these controllers down in the factories at all? Why do we need any, or virtual PLCs or like cloud PLCs? At some point, there's an interface down on a conveyor in a building someplace. But we'll just have that be kind of dumb, and everything that's intelligent, everything that's software-wise, will be operating in a cloud layer or in some distributed data center someplace. And
that's Vlad's vision of the future that I make fun of him about once a quarter. Yeah.
Yeah. Okay. I could see that too. I mean, I could see places where that makes sense, and I think it's a hybrid, or it's a continuum, because we have done stuff where. We've done stuff in the other direction too, where we put stuff underneath that's super smart, and this other thing is just turn the lights on and off. But that makes sense. But then you're like, okay, what new things are you introducing? Now you gotta. It's just a different way of dividing the problem. I could see that. Now you're managing a gazillion devices out in the world. How do they know where they are? It's like, this is more of like an IoT dream, which, I mean, is also cool and also coming. I would feel like, and that makes sense too. And maybe they're both on top of each other. I don't know. But like with universal I/O modules, or like at the point level, I could see it. Another question would be like, why are there any signals at all?
Okay.
Why isn't my sensor just shooting that straight up to whoever needs it instantly? There's a chip reading the analog circuitry there. Why doesn't it also have a power over Ethernet on it or something? Right? Like why is there any signal level? Why is there any 24-volt signal level? It's because it's standardized. It's because that's a universally agreed upon and reliable way to connect to things that we trust. And even all the IO links and power links and EtherCATs of the world still have their quirks, or their that's not quite at the level of, or even USB for that matter. USB can be quirky too. So those are all things that when you see how ubiquitous it is, you kind of know that it works, right? That's another thing. It's like how is something going to be that good, or it's got a long history? You can expect it to be around a lot longer. That's another way of thinking about it. But yeah, that's a cool idea, and you see it happening in different pockets. You see it happening with IO-Link. It makes sense because sensors are smarter and they need to be configurable. And why are we running any wires? Why are we running any wires anywhere? Like those are good questions.
Those are.
I think, in Dave, if I can interject like a quick point, I think in very, let's say, like high speed applications and like the edge cases, it might be critical, right? Because the way I understood signal processing, when it's converted from, let's call it, you put in a 24-volt signal or you put in an analog signal, it still needs to do that digital to analog to digital conversion, even though it puts in a digital signal. So it takes you more time. So I think if you introduce modules at the sensor level, you might not get the same latency. You know what I mean? Like, so if you have just a switch that closes, let's call it on 24 volts, and obviously there's some delay between that switch is made, but you still get an instant signal. Well, I mean, like a relay, right? Like
this is why it can't be wireless.
That's 100 milliseconds when that does that. Yes, that's why that's a problem.
The time.
It's so interesting to talk about, although it's more of like a hypothetical thing. But there's elements of that that are already happening now, which is there are ways to get clock determinism across big network, time determinism, right? Like, even it's still a little bit vaporware feeling to me, but when people talk about TSN, they're talking about time sensitive networking. They're talking about I can guarantee the timing of this information and it's transmitted. It's like it can be measured. So you can do real-time things across non-real-time networks, as long as they support TSN, right? And those are examples of, hey, I saw this edge go high at this nanosecond. You can already buy IO slices from BNR that will tell you that, or maybe not nano, maybe microsecond. This microsecond I saw an edge, and that time is clocked to the network time of the machine, which is clocked to every servo drive and every other IO signal. You can reconstruct those things across networks because the timing information is packaged with the data, with the signal level. And so oh man, see, this is the kind of stuff, Vlad. We gotta have me back for another episode about that.
Yes, I love that. I love the self-promotion of this, David. It is my favorite thing. Whenever we have you on, I'm excited to continue into this, but first I want to go let Chuck introduce Horner Automation Group to everyone.
Horner Automation is a division of Horner Electric. Horner Electric can trace its roots back to 1949, when George and Mary Horner started their small family-run business, which is now a large, thriving family-run business. Horner Automation has been in operation for over 35 years and is headquartered in Indianapolis, Indiana. Horner designs, builds, and markets a wide array of industrial all-in-one controllers, consisting of programmable control, HMI, I/O, and networking, along with software and peripherals. Many of our automation products are manufactured and assembled in the USA. At Horner, we support our partners, distributors, and customers by providing quarterly factory training on our products and software, as well as an extensive YouTube presence of videos that include software and hardware tips, training, industry solutions, trade show clips, new product releases, and much more. Horner strives to provide value-added solutions for our customers. We have availability, an option for every budget, and incredible support and resources to help your project run smoothly. Everywhere you look, Horner Automation controllers are there.
Awesome. So thank you to Horner for sponsoring this theme. Thank you to Chuck for putting together that nice voiceover so that I didn't have to say it. Please check everyone out at hornerautomationgroup.com. We'll go ahead and post the links in the comments, and Chuck will actually be on to talk about all of the all-in-ones as they were describing as part of the factory hardware, our reinvented series, which I'm excited about because we have not had an all-in-one conversation. I don't think Vlad has an all-in-one behind him at the moment, which we may have to rectify at some point soon. David, I want to I feel like we could continue on this conversation for no less than 6 hours. I know because Vlad and I have had this conversation for 6 hours, but I want to slightly transition to something else that you guys are doing with SASE. For everyone who is not involved in SASE, can you tell us what it is, please?
I would love to. So if you've heard me talking about software engineering and its applicability to automation, that is what SASE is all about. And the acronym SASE, which the pronunciation of it's really important to me and definitely intentional. The Society of Automation Software Engineers. And so thinking about these themes, working in this way for a long time, I didn't feel that there was a particular clear label for it, for what we were talking about. And so that's why we came up with that Automation Software Engineer title, and the Society of Automation Software Engineers to be the group of people that want to get together to promote that topic, to work together to help each other out. And so, yeah, we launched it right before Automate, and it's modeled after a professional group. So it takes inspiration from IEEE or ASME or any of these other orgs that are for particular types of engineering, because let's talk about our work, let's share what we've learned, let's help each other out, let's do some standards, let's have a conference. These are all things that we're imagining for the future, because we think that software engineering within automation is a distinct discipline and something that needs its own representation and sort of interest group, because automation is already really multidisciplinary. Then the big automation groups are, it's not necessarily a priority yet for a lot of those groups. And we just wanted to have that kind of clubhouse to get together and talk about that without being the focus. So that's what SASE is. The URL is sase.space. And we launched it as a Slack group first. And the reason that we did that was because we have enough people to have a community, but we're all spread out. We're all in different states or countries. so far primarily in the US and Europe, of people that are using these tools in these ways. And we wanted to have a way to connect with each other really real time and just like get to know each other, kind of form a collective. And so that's what SASE is right now. You can, and I would encourage too, we were actually talking about it this morning. If you're interested in this, or you consider yourself or would identify as a noob, you're also welcome. If this is cool to you, please join. Please come and hang out and watch all these gurus argue about with their curly braces or whatever they're arguing about. Just watch them and watch what they care about. Please join and hang out if this is interesting to you. And yeah, we've got a lot of other interesting stuff planned. Maybe we'll start doing some events or something. But yeah, if these ideas sound cool to you, there are ways to do this work. If you're like, I wish I could do that, only I have to use blank over here, then maybe come meet some people that are doing other stuff, and that could be a cool opportunity for folks.
I wanted to ask you, David, maybe to transition us from that, a question that is a bit, on the hardware side, but a bit dear to my heart, because I've seen those projects and I think that it's an important point, which is obsolescence, right, in the manufacturing hardware space. And you've certainly hinted at it a little bit earlier, when you said that in manufacturing, I think we want to have, we're different than, let's call it, the, how to say it, like the B2C market for electronics, right? Where things are changing every year. Your phone gets replaced, you throw it away. There's a new chip that comes in. Same for video cards, graphics cards, like whatever you call it. In manufacturing, hardware needs to last, I want to say at a minimum, a decade. But in reality, I think it's like 3 decades. And I'm curious. So I'm curious to see like what your thoughts are, like even, like outside of, let's call it like BNR, how do you look at hardware components when you want to evaluate them for, like that aspect? And maybe also, what do you see as like changes from that perspective? Because I think that there's necessarily no regulations when it comes to that. Like
right, or there isn't a particular like stamp you can get on something that I'm aware of that would tell you, what it is. And I think, and it's a complicated topic, but there are, it's something really interesting to speak to. I think you're right that when you talk about chips going into consumer electronics or other contexts, like it's basically disposable. You use it, throw it away, get a whole new one. That's not how production equipment works. That's not how capital equipment works. That stuff needs to be cranking out parts for a long time. And so you need to be able to keep the machines running for a long time in order to do that. And so there needs to be special attention paid from the very beginning of the hardware design cycle of, you can't just throw any resistor into this thing, because you need to be able to source the parts for decades into the future. Or you need to be able to have sourcing and people that are managing, if these parts are going away, we need to buy enough to last us through the usable life of our hardware, which is out in the field. And I've been working with, I will speak to BNR for a little bit, because I think they do care about it and they do manage it well. And they manage it as well or better. And I'll talk about it in 2 dimensions. One is the hardware itself. The hardware itself being available obviously is the best way to just pull out the thing, put in the new one, pull out the flash card, put it in, pull out the program, just keep it going. We got spares till the end of time. And not just from eBay, but we have legit parts. That is the company, you have to pay attention and do that well. And I haven't seen companies, even if you're packaging up an Arduino or you're packaging up a Raspberry Pi, like I don't see they're not made in the same way. They're not designed in the same way. And we saw that with a lot of the disruptions that were happening. Even these companies that are really good at it, like were redesigning their parts on the fly just based on parts availability, because they needed to. They needed to be able to have any components or any parts. And so that is a big task. And there's a reason why they are industrial companies. There's a reason why it's cost different than the cheapest stuff that's disposable. And I think there'll always be a place for companies that are willing to make those kind of commitments over a really long time span. And they can only make so many guarantees, right? And they can't predict the future. But there are different ways to design it intentionally so that they can deal with that. And that's a profession. That's an entire discipline of managing supply chain for industrial sourcing of electronics. And it's not that old, because electronics and machines must be 50 years old at most, 50, 80 years. So I think companies like B&R and others, when you walk around, you can see that they talk about it. They're proud of it. They're proud of what they do. And I remember going in there and seeing hardware that they were still shipping in 2010, 2015. They were talking about that had been shipping for more than 30 years or more than 20 years.
Wow.
You still get it. And their last time buys and their lifecycle managers were like, listen, this part is not going to be available in 5 years. So you need to start thinking about it now. And they would tell you that, and they would do that on purpose. And then they would say, and how are you going to transition? Because the last thing that even worse than that is like, hey, look, some parts are going to go away at some point.
Mm-hmm.
At a certain point, there's enough parts that are unattainable. You can't continue to produce the product. And in that case, you need to be able to take the IP that you've created and invested and move it onto the new stuff with a minimum of fuss, right? And how can you do that? And there are companies that I'm aware of that have gone through those type of transitions where it's a cliff. And it's like, hey, we programmed it this way with this old tool. Now there's a new tool, and maybe we have a converter, and maybe it'll work, right? That's what. Then they're like, just go rewrite it. It's your problem.
Well, that's where the fun is. Or you come
I
in and you're like,
I don't mean to take away all the great work you've done over your career to rewrite code that was going away. I don't mean to criticize that, but it's like that. How can you keep the stuff moving? And it's really cool, and they have some really badass stories about, for example, the drive firmware that runs in B&R drives is compatible and has been continuously backward compatible since the 90s.
Wow.
Right? And so it's like, yeah, that drive family just got retired. It had an amazing life. It had a 20, 30 year time span. And, we have here's all the last time buy stacked out. By the way, the new stuff is drive compatible, drive parameter compatible in a way that's totally reasonable to transition. And you can do both in the meantime. So you're not getting stranded, right? Like code base getting stranded are the most nightmarish thing, because people worked on that stuff for 10 years. That's where the value is. That's where all the engineering and amortization has gone in. And if that thing gets stuck, that's why people don't want to transition either. They can't bring it forward. So I think there's also, there's something to say for the software tools about that too, because that's a software tool kind of a problem. Can we keep deploying onto newer stuff with the old code base? How can we bring the code base forward, even though the hardware has gone through several generations of changes and new stuff? And how can we keep it on the new stuff as the new stuff comes out? There's a lot of, new stuff is faster, it's cheaper, do more with it. Like that, that's the cycle, right? Both like, how long is this piece of hardware available? And how is the platform managing, in B&R terms, generation 2005 to 2008 to the, X20 series, to IP series. Can you just leapfrog around without rewriting everything? And you can. There's some talk like that with IEC stuff, but even IEC stuff can be quirky, or structured text. There's ways, you can copy paste in any platform. Right. If there's standardization, like there should be with IEC languages, but even that runs into all kinds of headaches. Right. So it's like, can you keep on a platform continuity? And there's companies that can speak to their decades old track record of being able to do that. We can expect it to continue, right? They're not newcomers at this point about doing that. They're not new entries. They've been doing it forever. So that's where there's a big difference in why I'm saying, like, we're not just, yeah, it's cool, or, you're whatever. I can redeploy my Arduino on some new Arduino probably next year, but I'm not building my entire company on it. Like that.
And it's an interesting challenge.
Yeah, right. Because it doesn't stand still. And you can't predict the future.
I'd almost wonder what kind of almost architecture it would take to think, 30 years ahead. I think it probably is a very difficult challenge, right? And we can only appreciate someone who can design in a way that is, I want to say modular enough. I don't know if modular is the right word, but foresightful enough.
Architecturally, yeah.
Yeah, it must be really tough, because again, I'm sure that they internally, after let's say 10, 15 years, they still think like, well, maybe it is worth switching to something else because of benefits ABC, but does that outweigh, getting all of our customers angry because we have switched over, right? So there's a lot of
nuances. Who's the best at it as an analogy, not directly comparable, is like Apple. Like if you look at what they did with the Intel transition, and then that from PowerPC to Intel to their own chips, completely different bare metal architecture underneath, and they were able, again, there was stuff that fell away, But like to be able to manage those types of transitions is like, it's something that you can manage as things change. They're able to, how can we bring this stuff forward? Like they did these amazing tricks. They would give people plenty of warning. They had, because they needed to for their survival, or because of performance, or because, you know, because then they can make products that were better than any other products. And those kind of platform transitions would take place, and they're not uncommon, but you can do it well, or you can really screw it up. So I think, and you can strand your users, and that's good. So I think, yeah, there's a lot of cases, and there's good stories about how to keep that going, because it's not stuck. It shouldn't be stuck in one place. You know, like it's a dynamic process to keep your code and your IP onto the thing. And if some vendor throws a cliff in front of you, well, that would be a good time to look at a new platform. And I suggest you should look at BNR. But like that's like, right. And there've been plenty of times where that's been the case.
Dave?
I love this. I love this conversation. I agree. I feel like Apple, well, you either love Apple or you hate Apple. And so you either think that they did a really good job on the transitions, or you think that they're fools. Right. Yes. Or you think that they're fools for transitioning. I want to go back to the comment you made of, you know, you call BNR, for instance, and they say, hey, we can go sell you this, but we're going to no longer make this in 5 years. One of the most frustrating things that I've experienced is going and working with end users, and end users really wanting to go buy this new thing because it's at, you know, this hot, cool company, and someone said, hey, they use these IPCs, or they use this thing, and you go and you try to get pricing, and they're like, we can give you pricing, but we're literally obsoleting the entire line in 6 months, and you do your best job, and there's a 0% chance you can convince them to go to something that will have 5 years of runway or 10 years of runway for less money, right? And so I guess in your opinion, David, if you're talking to an end user, what is the kind of minimum amount of time you would want basically any device to be on the roadmap and still fully usable and capable before it gets obsoleted?
Yeah. I think the answer to that question is just about the trade-offs, right? It's just about what are you investing? Because if I'm writing a micro PLC application today, and I write it on an Arduino Uno and I ship it out there, I could hand that to an intern in 3 days, have it deployed on another thing when Arduino cancels that, because it's so simple, right? But we work on stuff often that's so complex, and there's been so much engineering put into it to make the machine work in the first place. People are investing millions of dollars. And so the stakes are higher, right? If it's something where, if it's anybody can do it, or what's the cost to replace it? What's the cost to rewrite it and redevelop it? Like that's still acceptable in a lot of cases, right? Like look at what Vlad's done, right? Vlad's like, I'll rewrite it for you all day long. Like, and it'll be good value work for Vlad to do it cheaper than, you know, whatever. Like it's a reasonable choice. It's a trade-off. But if you're shipping hundreds of machines in the field, and you have you're an equipment builder that's selling $100 million of tools every year and has for 15 years, think about what's out there. You know, you're going to be letting down your customers if you can't keep those things running, and you can't, you know.
I can hire a few extra guys.
Pick up the tab for a rewrite. You know, that's no fun. So it's that kind of investment. Where are you going to build? What are you going to build on? You're going to build on a place where the shoreline is receding. You know, like or a hurricane comes through everywhere. I don't know. Just in a floodplain, natural disasters. I don't know. That's what's coming to mind. But I think, and yeah, there's some that have that reputation, and they've shown that, and others that are promising and do interesting things, but maybe don't have that yet. And as the lines get shifted a lot, where you're like, well, I can just, all I'm doing is getting IO signals up to MQTT to this other stuff. And we're pretty sure that AWS is not going away for a long time. So like, we'll just build there. And if the IO changes, no big deal. It's all just components. It's all just pluggable. Those are all design and engineering trade-offs, right? It's not a yes or no question, unfortunately. I personally, you know, it's cool to work on stuff that has a lot of that investment and energy behind it, because usually that means it's important and it was hard, right? Like that's the kind of stuff that we like to do. So yeah, our stuff is usually not that throwaway.
I would say, I think maybe the comment for me would be, it's important to at least be cognizant of those timelines. I think we've discussed this a little bit off stream, that I think there's just not enough R&D time spent to, at the very least, research what you're putting in. And so I think the three of us have at least seen posts where, you know, there's a end of life cycle system going in, and you can't just, you kind of shake your head and you're like, oh, well, good luck to whomever purchased that. But ultimately, I think just taking the time to research what's going on.
And I think you when you're talking to people, you're like, okay, so let's imagine 8 months from now, somebody drives a forklift through that HMI. What happens next? And by the way, there's like a 50-50 chance that you'll be able to buy that part.
Yep.
And that means like we're going to have to do a crash engineering project to like adapt, replace, and yeah, maybe an IPC that's running some straightforward whatever. Just like, we just put in whatever. Who cares?
Yep.
Like, and that's a legitimate thing. That's a legitimate choice. If it's, you know, integrated in mechanically and it has special buttons and, you know, like you're like, there's nothing that could replace this, then you need to make sure that you can buy or you just buy a spare. That's another thing. Buy spares, right? Like hardware fails, stuff breaks. Like that's another thing that I feel like people are punishing themselves unnecessarily about because they're not doing appropriate risk mitigation on their spares. Because they haven't thought it through, right? It's just like that. You're gonna drive around with no insurance. Like it might work for a while. It's that kind of a puzzle. And yeah, it depends on if it's an IPC or if it's doing some special process that was tailor made for this certain black box that you can only get from wherever, and then it goes away. Then you got to start over from scratch, right? Those are the choices. What happens when it breaks? It's kind of funny, but I've been making the case or talking about it almost as a joke that we should start using iPads for every industrial HMI because they are stocked at every Walmart and they cost $300. And you can throw them on the ground and smash them to bits all day long, and you can always get a spare in 2 hours or less. So why don't we do that? And you're like, but that would, no. It's like, okay, well, again, we haven't convinced anybody to do that or try that yet, to be honest. But it's an interesting question, right? And if it's a web page that's your UI, really, or it's an iPad app, Apple's managing all the platform transitions to keep your apps running, and they do a pretty good job. So why don't we do that? You know, and to that matter, there's a difference between Android and Apple tablets in terms of how different they are or how weird they are. So, you know, go to your local Best Buy or order one on Amazon and get same day delivery. Like that's the kind of thing that I could see happening in certain pockets, right? That's just a UI. That's just a screen.
Really, if I was a distributor getting, you know, 5 or 10% of a $5,000 HMI, I'd get upset by that idea, but
I am that. That's what I am. I sell $5,000 HMIs, Vlad. Yeah. People don't want to. They want to keep buying them sometimes. So,
I have certainly worked with worse concepts and worse HMIs than go to Walmart and buy the $329 iPad, right? And I feel like we all have. I'm not sure that we're there yet, but I certainly see in the future.
No.
I certainly see in the future where that becoming more and more of a possibility. But no, David, somehow every time you come on, the time absolutely flies. I want to ask you a question that I feel like I have prepared you to as to what the future is going to be, and you have like only alluded like 7 or 8 times that we can't predict the future. So I am going to ask you to predict the future. What does the future of hardware look like, or what does the future of hardware software combination look like going into the next 5+ years?
The hardware that's going to grow the fastest and be most impactful will be the stuff that can bring the most software engineering capability to the world. Like that's the stuff where there's the biggest opportunities, and those are the ones that I think are best positioned to bring that to people. And there's a lot of people out there, a lot of SASE members that know how to do that and are really trying hard to bring that about. So I think it's all about how do you adopt those tools. And I didn't mention them already, but I mentioned B&R and Beckhoff, which we're fans of, and even Siemens. Mm-hmm. If you look at what they're doing with AX, they're saying exactly the right thing. And again, I'm reading press releases, but they're talking about package managers. They're talking about everything source controlled, everything runs with Git, and it's like that's the idea. That's the exact same idea we're talking about. Mm-hmm. So if that becomes real, like you'll be hearing about it from me too, because that's the way I see it going.
What about maybe technologies? If I can ask you, like, as a follow up to that, do you see maybe like robotics being a bit more, I want to say, like advanced? Do you see, I don't know, drones in manufacturing, VR, augmented reality? Like Apple came up with a
Oh
headset. So I
yeah.
think there's a lot of different verticals, right? There's machine vision that's being more and more sophisticated. Any thoughts on maybe like that side of hardware?
I'm just going to keep repeating myself because once those platforms are legitimate software tools, once they're able to adopt and everything that software connects to everything else that's software. Like once you do that, you're plugged into everything else in the world. So I think you can do that with a network cable. It's old stuff, but that's why we're trying to get it on there. Once we're using software tools in PLCs, we can show digital twins in Unreal Engine because Unreal Engine can talk to any other piece of software, right? It all plugs together.
Mhm.
And so, yeah, I think that's why it's so important. That's why it's so impactful to do. If you're cut off from that, like you're going to get left behind.
I like it.
I like that too.
Mhm.
David, every time you come on, you've got some awesome book recommendations for us. I'd like to know what you're reading, maybe what sort of interesting book recommendations you have for us this time, please.
I've got a good one for you. Although I was telling these guys in the prep that the technology stuff we're good at and we love and we're passionate about, but all of the stuff that I'm reading and learning about the most is all about like how to build teams, how to build humane companies, how do we treat each other well, and in the world that we live in. And I was handed a book by Vanessa, my people ops director of people ops, from Seth Godin called Song of Significance, which is really talking about what does it mean to do work, how has industrial work set up, and how's it been treating people, and how can you build the kind of companies where people can do important and impactful work and feel good about it. Like in that, it's a quick read, but it's really inspiring to think about how can we build a company where people can do meaningful work and be treated as human beings. So that's what I would point to, and I suggest everybody check it out.
I love that, and I think that if people can do meaningful work, it makes everything a lot easier. So
Yes,
yes, so
and it's very valuable economically as well.
Absolutely.
So it's not just good feelings; it's also the right thing economically.
Absolutely, 100%. No, thank you for that. Next question, I'd love to ask for some career advice, maybe kind of early to mid-career folks. I'm going to steal the obvious, easy one of go join SASE.space and either feel free to contribute or go ahead and learn to see what a bunch of people are arguing about. Those people might include Vlad, as you guys know, above me. Vlad said he was one of the first like 10 or 20 members on SASE. So you guys can go get the full Vlad and the full, I don't know, a couple hundred other interested people. But beyond joining SASE, what sort of career advice do you have for folks?
I think maybe I was lucky, but I was really interested in a lot of these software tools since I was a teenager, since I was lucky enough to get sat down in front of computers. And I got hooked. And that's why I was really confident that whole time, even when this whole industry has been kind of, a bit of a laggard, to say it mildly, about digital systems and computing and all these software engineering techniques I'm talking about. That gave me the confidence, like that engagement and that belief gave me a lot of confidence, even though no one knew what I was talking about. And so I would encourage people, if they feel that way or they feel kind of like, this is really important to me, or I'm into this, like just to trust that versus, maybe what's around you. That would just be like good confidence in general to follow what's important to you. And if that I've never regretted doing that. I've really been rewarded for doing that as well. So yeah, don't worry that 99% of people have no idea what you mean. Just keep doing it.
I love that. I appreciate that. And then the last question for you is who should reach out? Who do you want to connect with? Is Loop hiring? Is Loop looking for more customers? Kind of your open forum for our audience.
Yeah, for sure. I think the biggest gauntlet I threw down for the team as we started working nationally, especially doing consulting, was we really want to get out there and meet every BNR and Beckhoff user in the country, maybe more broadly. If you're using those platforms, we would love to talk to you because we've been doing this kind of work, even just as peers, and like, let's share what we know. I'd love to hear from anybody who's out there using BNR or Beckhoff, and just get to know. That could be on SASE, that could be personally. Like we're just eager to meet that community of people because we're trying to collect all the people that are aligned in that way. Definitely. And if that's you want a job, or if that's you want to work together as a client, or you're interested in helping on stuff, like we're very flexible in how we would collaborate. But if we have that alignment, that's the most important thing.
Absolutely. No, that is awesome. I will go throw up one last comment from Johnny here, saying the advances in software are incredible, yet most engineers are still designing in AutoCAD and Excel sheets, which was very similar to one of the first applications that David talked about. But David, thank you so much for being here. Everyone, thank you for coming to hang out. Please check out loop.team. Please check out SASE. Thank you to Horner Automation, our sponsors for this week. We will say Chuck from Horner is going to come on next week, which should be a super exciting conversation. Talked to him a bunch of times. Every time we've talked to him, it's been an awesome conversation. Please go follow David and Loop and Horner if you guys haven't already, as well as Manufacturing Hub and Vlad and myself. If you guys have made it this far on YouTube or in podcast format, please go give us a thumbs up. If you're on a podcast, please do the like, share, and follow and rate us 5 stars. I have realized that when I continue to remember to ask people to do that, you guys do it and more people listen, which is just a wild non-coincidence. But until next week, we'll see everyone soon.